Let me just start. I was working with quite a number of teachers here in Turkey, and for this reason I dedicate this presentation to the teachers, to the mathematics teachers in this country. If you wish to contact me, please remember you have my two email addresses. One is on the Gmail, another one is on Yahoo. They are the same. I check them every day. So this is the easiest way to contact me. Okay, are you okay? Come on. A few words about me. During the first day I presented myself, but just quickly about this, what I am doing and where I am. I was born in Poland. I was educated in Poland. I got MSc and PhD in mathematics, in geometry. My PhD was really in quantum mechanics, but I applied geometry methods to this. Then I was working in a few places. I was working in Poland. I was working in Papua New Guinea. This is a very nice island on the Pacific, near to Australia. Then I have moved to China, where I was opening School of Information Technology. Then I have moved to Zayed University in United Arab Emirates. And finally, I have moved to New York Institute of Technology, still staying on the campus in Emirates. My interests are mostly related to geometry, geometry in art, geometry in architecture, and there are a few areas which are really we've been working. One of them is the Chinese lattice, and this is something that I wish to present you during the next conference. And another area, this is Islamic ornament. I know quite a lot about Gothic tracery, but I didn't write anything about this until now. I wish to talk about mathematics, mostly about mathematics, and why? Because as a mathematician, as a teacher of mathematics, I'm really concerned about this, what is happening in this world. First, if you look what is happening in USA, in Europe, in Turkey, you still don't have this thing. But in Europe, in USA, the content of mathematics in the school was squeezed to absolute minimum. And this means geometry is gone. Practical is gone. There's almost no geometry. Instead of this, school mathematics, this is just computing, 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 computing. Okay? And in such case, what is happening really? The first, very low level of mathematics in the school. All over the Europe, all over the USA. The level of mathematics dropped down rapidly. In such case, you have problems with technical universities. All technical universities have not enough students. In Poland, in my country, the intake for polytechnics is about 70% only. So there are still free places, okay? The students don't possess problem-solving skills. They can calculate, but they cannot solve basic problems. There is also there's something that I wrote here, gap between good students and very low students. There's nothing between. And this is really bad because for the development, for example, of technology in the future, we need people in all levels. Then, for example, you have students of interior design, architecture, and so on. Can you believe they have to learn algebra? They never see geometry. So they really are not prepared for their jobs. They say, okay, we can use computers, but we don't understand what is behind of this. So my claim is Islamic art is the best way of introducing students to geometry, to problem-solving skills, and to many, many other things. So what I said on the beginning, what is important and why Islamic art is important for teaching mathematics. First thing is intriguing. You know what is intriguing? You're looking at something and you think, how they did this? Can I do it? Can I repeat it? Okay? So when my colleague was presenting today his presentation, there were quite a few examples which were intriguing. You look at them and you just think, how it was done. Just tell me how it was done, okay? The last pattern, the first pattern with these circles. When you don't see these circles, it is very difficult to say how it was done. Then Islamic art will develop students' imagination. You look at this and you start thinking how I can do it, if I can modify what I will get, and so on. It is developing a number of skills in mathematical art, in 2D and 3D geometry, and problem-solving skills. When you have really to find out how the pattern was done, you're just improving your problem-solving skills. So that's what I think is important when we teach about mathematics. Now, a few examples. I said Islamic art is intriguing. You know this door is Istanbul in Bayezid Mosque. When you're passing it on the side, how it was done. You have these stars, you see that they are, but you have to spend a moment looking at this. Okay, I have rosette here, I have rosette here, I have something here. How they are connected? What is the transition between this star and this star? So this is quite important. It is just asking your imagination to start thinking. Another design. It looks completely chaotic. Okay? It looks completely chaotic. But when you start looking at this, you will start thinking, okay, there's a star here, there's a star here, there is a similar star here. And again, you have a cosmos between them. How it was done. This is an example from Istanbul, from one of the Greek Orthodox churches. Something like this. We used to think about Islamic art as a 2D, as a plain thing. But if you're looking at this, this is perfect 3D example. And now, try to find out how they did this, how you can do it. You can invent a lot of methods for doing this, but how you can do it. Okay, Sultanahmet Mosque. I really like this example, and this photograph was done quite early in the season, and during the season you cannot do a photograph like this because this mosaic is on the entrance, is always dirty. You see the tourists are just going with the bubble gum, they're dropping it everywhere, and this mosaic is really dirty during the season. You have to come before the season or later after the season. You will see it nicely. And if you look at this, you can imagine how simple was the way of doing this. But from the mosaic itself, most of the people will be not able to tell anything. But you can just analyze this. So you're starting a process of analyzing. You look at this, you are looking for the places where the mosaic is repeating. You have this star, you have this star. So you start thinking, if I develop this rectangle, then by using simple mathematical operations, okay, mirror reflection, this is mathematics, okay? This is not fantasy, this is just mathematics. So using a very simple grid, mirror reflections, you create this pattern. This is a very nice problem for students from primary school or, let's say, beginning of high school. That's where you can introduce this thing. And you have this step by step. Create your square, okay? That's the square. Repeat it so many times, then you have this grid. You just making some of the lines of the grid stronger. Forget about the blue part, you get this thing, and you have your ornament. It looks like this. Now you can play with everything. You can play with colors, for example. Okay? This is your ornament, but this is not the real ornament. This is my copy that I did. Okay? And you can make it like this. Okay? And everything is just from this simple unit. So you have this rectangle, and that's all what you really need. Okay, let's go further. Okay, that's the door in one of the hotels in Istanbul. It looks like this. This is really still the same pattern. This is exactly the same pattern. You're creating a repeat unit like this, and this is just this fragment. And you're using these lines. You just draw one line more here, and you have this thing. If you get this blue rectangle, then using mirror reflection, you can replicate it to the right. Mirror reflection, you can go down. That's all. So you see very basic problem analysis. This is what is missing in the school. Okay. Now, quite often we are talking about different forms of Islamic art. And people say, we have arabesque, we have geometric ornament, and we have calligraphy. And they say, okay, that's geometric, that's not geometric, that's not geometric. I'm sorry, this is not true. This is not true. This is geometric for sure. We don't have any doubts. But if you look at this, what you see here, you see here spiral. Spiral, this is mathematical object. And ancient Greeks and later Islamic mathematicians, they developed methods for constructing spirals. If you look in the older books, you will find there's a lot of methods for creating these spirals, for connecting them. What about this thing? This is calligraphy. We say this is not geometric. Again, that's not true. Just look, this is mirror. Left side and right side are the same. This is mirror reflection. This way, you have again mirror reflection. There's more. If you draw a line like this one, this part and this part are mirror reflections. So that's a geometry, and in fact, that's a modern geometry, because we didn't talk about this type of operations in geometry for a long time. We started talking about them now. Transformations, this is modern geometry that we should teach. Okay, so what we have in Islamic art? We have geometric constructions, basic geometric construction. For example, like this one, dividing a segment in 3 equal parts, dividing a segment in 5 equal parts, dividing angle in a number of parts, creating polygons, regular polygons, not only hexagon, but polygons with 10 sides, 12 sides, and so on, okay? Then constructing stars and rosettes like this. This is still geometry, okay? And you're creating this one from shapes like this one. And then another thing that we are forgetting quite often, grids. In Islamic art, you have a number of different types of grids. This is mathematics, this is tessellations, okay? In mathematics, in modern mathematics, we talk about tessellations. So you have these things here, okay? And these are very basic operations, okay? This is what we should teach in the school, really, okay? And we are not doing this. So if you look at this, that's a square, that's a pentagon shape, and when you enter pentagon, you suddenly enter different world, okay? Because first of all, pentagon will not allow you to cover the plane. When you start covering plane with pentagon, you suddenly see that you're getting gaps, okay? You're getting gaps like this. You start with the pentagon, then you just put another one, and suddenly you have this. You're getting gaps. So you entering again geometry. What's wrong with pentagons? Why we cannot cover the plane with pentagons? Okay, what figures we need for pentagons to cover the plane? So that's quite a lot of things interesting here. And of course, you can just think, what kind of figures, what kind of polygons I can use to cover the plane? And there's a whole theory behind of this. There is a number of very good papers, and these papers or books can be at least partially done in the high school. Okay, again, polygons, regular polygons. This is what is missing in the school. Okay, creating some very complicated polygons. You see, here you're entering one interesting question. Some polygons, regular polygons, you can construct, and some of them you cannot. Okay, whatever you do, your construction will be not accurate. Okay, why? Okay. If you know mathematics, you know that there is a theorem saying which can be constructed, which cannot. But even if you cannot construct a polygon, a regular polygon, you have to look how in the past mathematicians and artists created these polygons. Okay? For example, polygon with 9 sides. You cannot construct it. Sorry. Your construction, whatever you will do, will be inaccurate. But still, there are methods that give you a chance to construct at least approximated version. Okay? So if you calculate, if you measure these sides, you will find that one of them is slightly shorter. Okay? Slightly. It is a small mistake. Okay? So that's a mathematics that is hidden in Islamic art. Then I said grids, tessellations. You can have hexagonal grid, you have square grid, you can have rectangular grid, you can have triangular grid. You can deal with a number of interesting grids, okay, and you can build your patterns using these grids. If you just think, okay, that's my repeat unit. If I take this, then what I do, I created this pattern that is inside of this just using this method. Okay, so that's fine, but this is still a bit of problem solving for the student. Okay, so you can have various type of grids. Just can you imagine a grid like this? Okay, and can you imagine that there is quite a number of examples in Islamic art based on these grids, on grid like this, on grid like this. Okay, so that's a whole story of tessellations that you're getting in the school. Okay. Okay. Let me jump to the example. Sultanahmet. I know you like this place. This is the most important place in Istanbul. When you're entering there, you see a pattern like this. This pattern you see, in fact, in many other places. For example, if you go here to the Sultanahmet Mosque, you will find on this round fountain exactly the same pattern. Okay, so after the workshop you can go there and you can check how this pattern was created. If you give the problem like this to your student, he will have to just find out what is the base for this pattern. And you have really two options. You have one option, just choose this part and try to develop this part, or choose this part and try to develop it. If you have this part done, then by mirror reflection you're getting the next part. Okay? Just look from here to here. This is the same like this one. So reflections again. So the only problem that you have in this moment is just guess what is this, how you get it, or how you get this. And that's a simple thing after, let's say, 15 minutes of looking at this. Okay? You're creating your square. You're dividing each side into equal parts, so you're getting the midpoints. Now, the first important thing, getting the angle 60 degrees from this point. This is one trick, okay? Just make arc from one left, okay, and you're getting 60 degrees. This is the line that you will have here, okay? Just look at this. This is the beginning for this line. The rest is just circles, dots, connecting them with segments, and so on. This presentation I can give to anybody if you wish, okay? So you don't need to copy it. You can get it. I have no problems with this. Anyway, step by step, you're creating a pattern like this. When you have this pattern, reflections. Again, mathematics. Reflections, reflections, reflections. So look at this. How much mathematics you have here? Creating a square, dividing segment into parts, creating angle 60 degrees, okay? Then in such case, what you do, you're creating circles, okay? That's not really a big problem, okay? And then connecting points with segments. This is not mathematics, this is just drawing, okay? And here, just connecting, finally, and again, you're coming to mathematics when you have to do reflections, okay? And that's the whole story. And you're getting this pattern, the pattern that is here in such a form. You got it, okay? You got it. You can take a piece of paper and you can make it nicely, whatever you wish. Now, another example. In Istanbul, in almost every mosque, you have doors and you have the covers for the windows, the shutters for the windows. And on many of them, you will find patterns like this one. These are very beautiful patterns, and you have to look at them as a part of something bigger, okay? Because this pattern, it is really part of something bigger. You see, here you have rosette, and this rosette is going out. Here you have identical rosette is going out. And this is the space between these two rosettes. How you can create it, how you can make it. Just look at this, okay? That's a construction step by step, okay? Here, there's one thing that is quite important. Whenever I start talking about Islamic ornament, I start always from the segment, okay? Why I start from the segment? You see, imagine, you have a board like this, and you have to cover it with pattern, okay? You have to decide in the beginning how many times the repeat unit like this will be repeated. How many times? You cannot break it in the middle, sorry, okay? You have to plan, and you have to plan precisely. So if this is, for example, 2 meters, let's say 2 meters, meter, one, just easy, okay? If I wish to have this pattern repeated 4 times, I have to divide this 1 meter into 4 units. So before you start any drawing, before you start any work, think, how big is the area you wish to cover? And start drawing the picture like this by precisely saying what is its size, okay? When you know, my board is 1 meter and I have to cover it 4 times, so my repeat unit is 25 centimeters. If I wish to do it 5 times, then my repeat unit must be 20 centimeters. So that's where we are. A bit of planning. Okay, and in Sultanahmet Mosque you have quite a number of examples like this. They are old examples. In many mosques you have new examples that were created recently, reconstructed or created fresh. Okay, but this one is old one. It is slightly complicated, but what I wish to point you, in Islamic art, there's a slight difference between Islamic art. Okay, there are many differences between Islamic art and the Western art. In the Western art, I talk about the ancient art, the major proportions were always a golden ratio. Most of the designs in Greek art or Greek architecture was based on square or golden ratio. In Islamic art, you're getting quite a number of interesting proportions. For example, this unit, okay, has proportions like this. If A is equal A, okay, then B is equal this. This is the proportion for this repeat unit, for the pattern like this. You will be surprised that in Islamic art you will find a number of very interesting proportions. Not only the golden ratio or not only the square. Square is popular, I agree. But many other proportions you will find, and you will see that they are there. So in this case, in my opinion, Islamic art is, let's say, richer. You get a lot of diversity in Islamic art. Okay, another example. Again, Sultanahmet Mosque in Istanbul. I don't wish to talk about this. You can go through this presentation when you will have time. Okay, and then you can analyze this. Now I wish to go over the water. Have you been in Üsküdar? Who of you went to Üsküdar? Okay. You know in Üsküdar, Miroslaw Mosque. I was never lucky with this mosque. Every time when I went there, or it was closed, or there was light, something problems with the light. Now it was in reconstruction. But I was lucky to get this photo. This photo. And what is amazing in this photo, it is this pattern. This pattern is simple, okay? But this pattern here, it is something that is really interesting in Üsküdar. If you look at this pattern, you have this slightly bigger size. You have a feeling that this pattern is irregular. Okay? You have a feeling. Okay? Just look at this. For example, okay, I am too short for this thing, but look. 1, 1, 1, and suddenly jump like this. Okay? There is something that makes impression that this pattern is irregular. It is not. It is so beautiful pattern, and you can just look at this and you can just see how they made it. So the first thing, establishing a repeat unit of this shape. It is really square, only the photograph is just made from the side. You're taking a square, you're constructing a square, high school exercise. You divide this angle in 4 equal parts. It means 45 and 22.5, you're getting this. You're doing this exactly the same from the top corner, okay? When you do this, this is what I got in the previous slide. Now what you do, you just from this point, you're creating these lines from each of these points here. Okay, you're creating these lines. And how you made them? For example, you start from this point and you made a line that is perpendicular to this line. Okay, so from here to here, line perpendicular. And each of them is parallel to this one. Just basic thing from the high school. Parallel line, perpendicular line. This is what we should teach in the beginning of the primary school. Okay? And then, this is what I got in the previous step. Create another family of parallel line, starting from here and perpendicular to this one. Great, you can do it. This is just simple ruler exercise. Okay, and you're getting a grid like this, step by step. And then here slightly more complicated because you have to help yourself by drawing these circles, okay, but the points you have here ready for doing this. And when you get this, then just look at this pattern and try to distinguish what you really want to get out of this. So you're just taking these things, you're making them thicker, you're forgetting about the blue things, okay, you get this red pattern. But just in this moment, it is worth to notice, for a high school student, there are many ways of going from this point. Why? Because This way, I am just trying to recover the pattern from Üsküdar. But student may say, okay, but I wish to create something my own. Okay, why not? Use your creativity. You have grid, you have a grid like this, and you can make your own choice. You don't need to choose this square, okay? Maybe you can choose a triangle like this, and maybe something else. This is up to the student. Just having grid and going any way he wants. And out of these exercises, you can get quite a number of beautiful patterns, and some of them will be completely new, completely fresh. Okay, so this is what I got, okay? That's my pattern. After cleaning all these unnecessary lines, I got this. I got this. It looks quite nice. And now repeating this, again, there's a bit trick. I have this thing. This is what I had in the previous day. This is here. Now, there is no reflection in this pattern. This point is the point of rotation. You have this pattern and you have to rotate it 90 degrees, 90 degrees, 90 degrees. This is one of the very few examples in Istanbul where you have to apply rotations instead of reflections. Rotation, it is again high school exercise in mathematics. So you have it here. And then there is exercise in arts. Okay, you can use any colors, you can use any materials for doing this, okay? That's a color, this is like a glass window, okay? But if the brothers Molina will look at this, they will say, okay, I will use wood. Can you use wood for this? It's perfectly fine. So instead of using glass, you can use pieces of wood and you can make a nice floor with this pattern, okay? Or you can make a mosaic into your living room, or a picture to your office. So this is the pattern that I created from Üsküdar, from the beginning, the top square. This is the starting point, the grid, and to the end where you have this pattern done step by step, step by step. Okay, what mathematics we have to use here? Okay, let's make a summary. Very complex geometric constructions. Some of them were complex, some of them were simple. We used a lot of designing skills, and students are building their good designing skills. This way, your students will be able to develop their problem-solving skills. Then, from this point, you can go anywhere. Look at this pattern here. Look at this pattern. Ask your students how this pattern was created. What will be the repeat unit for this pattern? Is this pattern periodic or not periodic? We heard about periodic patterns here yesterday, okay? There's quite a lot of questions for the pattern like this one that you have on the right side, okay? Can you try example like this one? It's beautiful, okay? How to make it? Where to start, okay? Where to start? What is your repeat unit? You start from here, you're going like this, okay? This will be good start, okay? So this square can be repeat unit if you wish, but you can do much more. Okay, and now a puzzle for you. You have one ornament and you have another ornament. What happened here? Can you tell me what happened here? Are they similar? Yes or no? Okay. I can tell you what happened here. These are identical ornaments. This one and this one are the same. What happened from here to here? The picture like this was collapsed to the inside. It was inverted, okay? You know, when you're taking your shirt, okay, and you invert it on the other side. From here to here, this is inversion. This is inversion of this ornament. So, this line here, that is this line. This line here, that is this line. this line here, this is the left side, and this line here, that's the right side. Okay? Now, what happened to this star? Each vertex, each internal vertex of this star went outside. It was just inverted, okay?
Okay.
But, okay, just
on the circle.
Okay, this is inversion on the circle, yeah. Okay. In mathematics, we talk about inversions, and we're talking about inversions about many things. Here, inversions was the circle, okay? So there was a circle, and everything was inverted outside of the circle, okay? But then this is the simplest case that you should know in the high school. Okay, now let me to summarize everything. This is whatever you have here. These are mathematical topics in the high school mathematics. All of them, each of them is in Islamic art. Okay, and you can talk about these topics on various levels. You can talk about them in the primary school, simpler examples. You can talk about secondary schools, more complicated examples, and you can talk about them at the university level where the examples are getting really much more complicated. So you have all this mathematics there, and you can just use this thing. Now, last question. That is in Istanbul. Did you ever see this mathematical mosque? That's a really mathematical mosque. You cannot believe how much mathematics I see in this mosque. Okay? I put the name. Did I put the name? No, I didn't put the name. Okay, that's good. Who knows what is this? This is on Uskudar, on the top, next to the cemetery. Okay? Go there. Believe me, it's a beautiful mosque. And all shapes in this mosque are mathematical. Even the minbar here, it is hyperbolic curve. Come on, that's a hyperbolic curve. It is part of hyperbola. Okay, the shape of the whole thing. This is a spheric cut from 4 sides. Okay, that's really mathematical mosque in Istanbul. It's very new. Thank you.